During forensic evidence gathering, it can sometimes be critical that we capture an image of what was happening in memory, electronic memory or RAM, at the time that evidence was seized. There are many ways we can do that, and in this video, we're going to learn how to create a physical memory dump. Now, there are plenty of tools that will run on Windows, Unix, and Linux. Some of the tools might run off a USB thumb drive that you plug into the machine itself, whose memory you want to get a dump from, and then maybe you would store the memory dump on a USB removable drive or send it over the network. The way that we're going to do it here is we're going to begin in Kali Linux using a Netcat listener, or NC, as you can see with the command. We're going to listen for connections over the network where we can receive a memory dump taken of a machine elsewhere. So the command here in Kali Linux is nc for netcat -l for listen -vvv. Basically, the more V's you have, the more verbose the output is, believe it or not. -p for the listening port, which here is going to be 8888. And then that's followed by the redirection symbol, the greater than sign, so that we're redirecting whatever we receive through this port to a file on this Linux host called client memdump1.dd. Let's go ahead and press enter to start that listener on Kali Linux. And now it says listening on any, which means any interface, on port 8888. So I'm looking at a Windows machine where Internet Explorer is connected to a banking website. What we want to do is get a memory dump of this machine. So there are many ways to do that. What we're going to do is go to the Start menu and go to My Computer, where we've got a tool that was downloaded that can actually acquire a memory dump and send it somewhere, like over the network, and that tool is called Helix. If I go ahead and run the Helix tool, it gives me a warning that says the fact that you're running this tool is modifying this system. So when you're gathering evidence, that is important to note and it must be documented. I'll accept that by clicking the Accept button. And I'm going to click the camera icon on the left to acquire a live image. The source up here is physical memory, of which there is a little over 500 megabytes worth. I want to send it over the network to a Netcat location, so I'm going to put in the IP address of our Kali Linux host, which is listening on port 8888, and I'll click Acquire. So it asks me if this is okay. If I want to do this, I'm going to click Yes. And now it says it's copying the physical memory. Of course, it's copying it over the network to our Linux host. Back here in Kali Linux, we can see in fact that we've got a connection from a host called 192.168.1.242. Well, that's actually not what it's called, but that is its IP address. So now it's just a matter of waiting until we receive the entire memory dump before we can analyze it using a different tool called Volatility. We can now see in Linux that it received a number of bytes, and if we type ls, we'll see the existence of our client memdump1.dd file. So the next thing we'll do is use a different tool, and that's going to be Volatility, to analyze that file. So with Volatility, I'm going to use -f for file. I'll specify the file name, and the first thing we'll start off with is asking it to give us just a little bit of image information about that memory dump image. Depending on the amount of memory gathered, that might take just a few seconds or it might take a few minutes. Okay, so it looks like next to suggested profiles, it's a Windows XP machine, and further down the number of processors is set to 1, and then we have image, date, and timestamp information listed down below. I'm going to use the up arrow key to bring up that volatility command again, except instead of image info as the last parameter, this time we're going to use pslist to give us a list of running processes at the time that the memory dump was acquired. And sometimes that can be absolutely crucial when it comes to evidence in a specific case. So we have a list of the processes here, and of course we see the date and timestamps over on the far right. Let's clear the screen and bring up that command again, and let's change the last parameter from pslist in this case to conscan to show any active connections, again, at the time that the memory dump was acquired. Here we can see we have numerous connections to something on port 80. We can see IP addresses. Now, of course, there are ways that we can conduct reverse lookups, for instance, using NSLOOKUP, which I can do here in Linux. I can set type equal PTR to do a reverse pointer lookup, and maybe I'll pop in the first IP address I see here. And then I get answers back that are listed from that. I get a non-authoritative answer, which means it came from a different DNS server. You can see that we've issued the volatility command against our dump file again, but we've used as a last parameter clipboard to show us the contents of what was copied in memory. And notice that under the data column on the right, it looks like we've got some kind of variation of my dog has fleas, which appears to be some kind of a password. So we can start gathering some very detailed information from what was happening within a memory dump at the time that it was acquired. In this video, we learned how to create a physical memory dump.